You know that feeling, right? You're on a train, maybe with a cup of coffee, and as it starts or stops, bam, that sudden jolt. We've all been there. Well, today, we're going to pull back the curtain on the incredible and pretty much invisible engineering that's designed to make that jolt a thing of the past. And hey, this isn't just something we passengers complain about, it's a huge deal. This quote is from an official railway document, and it shows that these longitudinal jerks are a serious system-wide problem that some very smart engineers have been trying to solve for a long time. So, what's really going on behind that jerk? It's so much more than just a bumpy ride. It's a symptom of these massive, invisible forces clashing between train coaches that each weigh tons. Taming those forces? Now that's a real engineering puzzle.
Okay, let's get into the specifics. The technical term is longitudinal jerk, and it all comes down to one little thing: slack. You see, there are tiny gaps between the coaches, so when the engine pulls or the brakes hit, that slack vanishes in an instant, creating a shock wave that travels right down the train and, yeah, right through your seat.
But where there's a problem, engineers see an opportunity for a brilliant solution. So let's meet the hero of our story today. The piece of technology designed to create a perfectly seamless connection and, hopefully, get rid of that jerk for good. I know, it's a bit of a mouthful. The AAR H-type tight-lock center buffer coupler with balanced draft gear. But stick with me, because we're going to break down what every single part of that long name means and how it all works together to give us that super smooth ride. And to really get why this is such a game changer, you have to see what it replaced. The old system, called screw coupling, was loose, it was manual, it was just prone to jerks. This new center buffer coupler, or CBC, gives you a tight lock connection automatically. And here's the magic number. The slack is reduced to just 2 millimeters. That tiny difference is the key to a nearly jerk-free ride. All right, so let's pop the hood and see how this thing actually works. How on earth does it manage to absorb all those massive forces and make a whole train feel like one solid piece? Inside the coupler is a whole collection of super strong steel parts working together. You've got the knuckle, the lock, the knuckle thrower, the toggle, but the real secret weapon, the thing that does the heavy lifting for a smooth ride, is something called the balanced draft gear. So let's start with the knuckle. Honestly, the best way to think of it is like a handshake. When two coaches are pushed together, these knuckles literally interlock, creating that first strong physical connection. It's the first point of contact. Okay, so once that handshake is made, the lock just drops down into place, securing the knuckles. This is a huge safety feature. It makes sure that once those coaches are connected, they are not coming apart. It's totally automatic, totally reliable. And now for the star of the show, the balanced draft gear. Think of it as a giant, incredibly smart shock absorber. It's packed with these special pads that squeeze and expand to soak up all the energy from any pushing or pulling. This is what turns a violent coffee-spilling jolt into a gentle, barely noticeable nudge. So just how strong are these couplers? Well, the forces they're built to handle are, frankly, astronomical, and the tests they put them through are absolutely brutal. Check this out. During testing, this coupler has to handle a pushing force of 2,000 kilonewtons. To put that in perspective, that's like taking about 130 cars, stacking them all on top of each other, and putting all that weight on this one single point. And it can't break. And then they try to pull it apart with a force of 1,000 kilonewtons. That's over 100 tons of pure pulling force, making sure a train that can weigh almost 2,000 tons stays in one piece no matter what. And of course, it's not just about straight line forces. Trains go around corners, they go over uneven tracks. So a bending test of 300 kilonewtons makes sure the coupler can handle all those twisting stresses without failing. So what's the secret sauce? How is it so strong? Well, it all comes down to the steel. It's a special recipe called ASMER M201 Grade E. It's got a very precise amount of carbon and manganese for hardness, and they make sure impurities like phosphorus and sulfur are kept incredibly low. It's basically a super steel. Now, having a great design is one thing, but making sure it works perfectly day in and day out on thousands of coaches across the country, that's a whole other challenge.
And maintenance is an exact science. There are very strict do's and don'ts. For example, you have to apply grease to certain parts to keep them moving smoothly. But, and this is critical, you must not grease the locking mechanism. Why? Because that would attract dirt and grime and could cause it to jam. And forget about hammers or tying things up with wire. Only the right tools for the right job. The inspection process is just as precise. It starts with a simple height check from the rail. Then technicians use these really specific tools, like a contour gauge, to make sure the knuckles handshake shape hasn't worn down. Then they use a jaw gap gauge to check if the slack is getting too big. It's a whole routine designed to catch problems before they happen. And all this precision really makes you wonder, right? With all this amazing strength and engineering, what could possibly go wrong? What happens if just one tiny, seemingly unimportant part gives up? Well, the result can be a complete disaster. This is a real-world example. A tiny part, a silent block bush, failed. That failure caused a chain reaction of vibrations that literally punctured the steel plate holding the entire coupler. The main pin dropped out, and the whole coupler detached. It's a scary reminder of why every single bolt and every single maintenance rule matters so much. All right, so what have we learned? First, that annoying train jolt is a serious engineering headache. Second, the solution is the AAR H-type coupler, which gives a tight lock connection using that amazing balanced draft gear as a shock absorber. Third, its incredible strength comes from super steel and some truly brutal testing. And finally, that obsessive, meticulous maintenance is the only thing standing between a smooth ride and a total catastrophe. So the next time you're on a train and it pulls away from the station with just a gentle hum, you'll know about the incredible engineering hidden away between the coaches. And it kind of makes you wonder, doesn't it? What other pieces of invisible design are all around us, just quietly making our world work?